Hello friends, good morning. So in this video we are going to cover some more sums of exercise 5.3. Then first question is question 10. We have to find derivative of inverse function. Now given function is y equal to tan inverse 3x minus x cube upon 1 minus 3x square, and given condition is minus 1 upon root 3 less than x less than 1 upon root 3, given condition, and this is given function. Now if we want to find derivative of inverse function, first we have to simplify the given function and then we can take derivative. Now for simplifying, here we can see that this term matches with formula as we know that tan 3 theta equal to 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So in given function, this term in bracket matches with this formula. Here we can replace, instead of x we can replace tan theta, right? Then only we can apply this formula. So friends, here we will assume x equal to tan theta. Then only we can apply this formula and simplify the given function. Now putting x equal to tan theta in given function, so we will get y equal to tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now by putting x equal to tan theta, we are getting the form where we can apply tan 3 theta formula. So for this bracket we are writing tan theta now. So tan inverse tan 3 theta. For this bracket we are writing tan 3 theta. Now tan inverse of tan 3 theta. So if we simplify this term, then tan inverse and tan gets eliminated and 3 theta will be your answer. But for this there is one condition, that 3 theta should be in range of tan inverse, and this value should be in range of tan inverse. Now range of tan inverse is open interval minus pi by 2 to plus pi by 2, minus 90 to plus 90. So we have to show here that 3 theta lies between minus 90 and plus 90. This can be showed by using given condition given here. So from this condition we will find range of 3 theta first, and then we can show that 3 theta lies in range of tan inverse. Let's follow it. So but minus 1 upon root 3 less than x less than 1 upon root 3. This is given condition. Now minus 1 upon root 3 means 10 minus 10 pi by 6 we can write. We know that value of 10 pi by 6 is 1 upon root 3. Now here minus 1 upon root 3 is there. So for minus 1 upon root 3 we can write minus 10 pi by 6. For x we can write tan theta, and for 1 upon root 3 we can write 10 pi by 6. 10 pi by 6 means tan 30. Now from this inequality 10 gets eliminated. Without 10 we can write minus pi by 6 less than theta less than pi by 6. So we are getting range of theta. Now we need to find range of 3 theta. So from range of theta we can obtain range of 3 theta by if we multiply here 3 in all the terms in this inequality, then we'll get range of 3 theta. So multiplying by 3, minus pi by 6 multiplied by 3 gives you minus pi by 2. 3 theta and plus pi by 6 multiplied by 3, so you will get pi by 2. So here we can see that 3 theta lies in range of minus 90 and plus 90. That is only thing that we have to show here. Now it is concluded that 3 theta lies in tan inverse range. So here tan inverse and tan gets cancelled, so y equal to 3 theta is obtained. Therefore y equal to 3 theta. Now x equal to tan theta we have assumed. So from this we can write theta equal to tan inverse x. So putting value of theta, tan inverse x here, so we are getting y equal to 3 tan inverse x. Now this is simplified term. Now we can take derivative of y with respect to x, that is dy by dx, and 3 tan inverse x, so 3 is coefficient remains same, and derivative of tan inverse x is 1 upon 1 plus x square. So 3 into 1 upon 1 plus x square gives you 3 upon 1 plus x square. So this is your final answer. This is required derivative. So in this way we can solve the question where inverse function is given. Let's see another question. Question 11. In question 11, given function is y equal to cos inverse 1 minus x square upon 1 plus x square. 1 minus x square upon 1 plus x square. And given condition is 0 less than x less than 1. Now as we know that cos 2 theta equal to 1 minus tan square theta upon 1 plus tan square theta. This is multiple formula. Now comparing this term with 1 minus tan square upon 1 plus tan square. So here we can see that if we assume x equal to tan theta, then example can be solved. So therefore let us assume x equal to tan theta. Now putting x equal to tan theta in given function, so y equal to cos inverse 1 minus tan square upon 1 plus tan square. Now for 1 minus tan square upon 1 plus tan square we can write cos 2 theta. So cos inverse of cos 2 theta can be written. Now here cos inverse and cos gets cancelled, so y equal to 2 theta can be obtained. But for first you have to show that 2 theta lies in range of cos inverse, and for that given condition is 0 less than x less than 1. This was the condition given. Now writing tan value in all the terms, we know that tan 0 0, tan 0 equal to 0, so for 0 we can write tan 0, for x we can write tan theta, and for 1 we can write tan pi by 4. Now without tan we can write 0 less than theta less than pi by 4. This is range of theta, and we need to find range of 2 theta. So multiplying this inequality by 2, we will get range of 2 theta. 0 less than 2 theta less than pi by 4 multiplied by 2, that is pi by 2. Now we are getting range of 2 theta. 2 theta lies between 0 and pi by 2, and we know range of cos inverse is close interval 0 to pi by 2, right? So it satisfies that this value lies in range of cos inverse. So now we can simplify and we can write y equal to 2 theta. Therefore y equal to 2 theta, and for theta value can be written as we have assumed x equal to tan theta, so for theta we can write tan inverse x. So here 2 tan inverse x. Now our function is y equal to 2 tan inverse x. This is simplified form. Now we can take derivative. So derivative of y with respect to x will be dy by dx. Then coefficient remains same as it is, and derivative of tan inverse x will be 1 upon 1 plus x square. So 2 upon 1 plus x square. This is our final answer, required derivative. Friends, this type of questions are regularly asked in exams. At least one question is always asked. So you need to do practice of this kind of sums regularly, and this type of questions are very important. Now let us see next question. In 12th, given function is y equal to sine inverse 1 minus x square upon 1 plus x square, and given range 0 less than x less than 1. Now in previous question we had used formula cos 2 theta equal to 1 minus tan square upon 1 plus tan square theta. So same formula can be used, as this form given in bracket is same. But inverse function given here is sine inverse, not cos inverse. So first we have to convert this into cos inverse. Let me write first formula that we are going to use. So as we know that cos 2 theta equal to 1 minus tan square theta upon 1 plus tan square theta. This is the required formula that we are going to use. But first, as this formula, from this formula we can write, for theta we can write cos inverse, right? So function should be in terms of cos inverse. Then only this question can be solved by using this formula. So first there is one another property from which we can convert this sine inverse into cos inverse. We know that sine inverse x plus cos inverse x equal to pi by 2. So making sine inverse x as a subject, we can write pi by 2 minus cos inverse x. So here sine inverse x can be converted into cos inverse x while writing pi by 2 minus cos inverse x. So our given function can be written using this property like this, that we will write like this, y equal to pi by 2 minus sine inverse term is given, right? So if we want to convert into cos inverse x, then we have to write pi by 2 minus cos inverse, and instead of x we are writing 1 minus x square upon 1 plus x square, that is given 1 minus x square upon 1 plus x square. So in this way we can convert given function into cos inverse. Now we'll apply cos 2 theta formula. For that, first we have to assume x equal to tan theta, and from this we can write theta equal to tan inverse x. Now putting value of x equal to tan theta in given function, so y equal to pi by 2 minus cos inverse 1 minus tan square theta upon 1 plus tan square theta. In this way we can apply this formula by assuming x equal to tan theta. Now for this bracket we can write cos 2 theta. Therefore y equal to pi by 2 minus cos inverse of cos 2 theta. Now for simplifying this, we have to show that 2 theta lies in range of cos inverse. So from given condition 0 less than x less than 1, this is the given condition. From this we will find a range of 2 theta. First write these all terms in form of tan. So tan, for 0 we will write tan 0, as we know that tan 0 equal to 0. For x we will write tan theta, and for 1 we will write tan pi by 4. Now removing tan, so we can write 0 less than theta less than pi by 4. We need to find range of 2 theta, so multiplying this inequality by 2 will get range of 2 theta. So 2 theta lies between 0 and pi by 2, which is already range of cos inverse function. Hence our term gets simplified as y equal to pi by 2 minus 2 theta. So we can write y equal to pi by 2 minus 2 theta. Now taking derivative, so derivative of y with respect to x will be dy by dx. Pi by 2 is constant term, so derivative is 0 minus 2 theta. So here minus 2 remains as it is coefficient, and for theta value of theta was tan inverse x. Let me write first value pi by 2 minus 2 tan inverse x. So now taking derivative of 2 tan inverse x, minus 2 remains as it is, and derivative of tan inverse x is 1 upon 1 plus x square. So minus 2 upon 1 plus x square. This is our required answer. So dear friends, now we'll solve question 13 of exercise 5.3. In this, given function is y equal to cos inverse 2x upon 1 plus x square, and given range is minus 1 less than x less than 1. Now as we know that sin 2 theta equal to 2 tan theta upon 1 plus tan square theta. This is the formula which can be applied here because this term matches with this term. Just we have to replace x equal to tan theta. So let us assume x equal to tan theta and write tan theta instead of x in given term. So 2 tan theta upon 1 plus tan square theta will get. Now for this we can write sin 2 theta. So y equal to cos inverse sin 2 theta. Now in bracket sin function is there, and out of bracket there is cos inverse. So here we have to convert cos inverse into sin inverse, and for this there is one identity, that is sin inverse x plus cos inverse x equal to pi by 2. Now sin inverse x plus cos inverse x equal to pi by 2. So from this identity cos inverse is to be converted into sin inverse, right? So making cos inverse x as a subject, so I can write pi by 2 minus sin inverse x. Sin inverse x goes on other side, so we can write pi by 2 minus sin inverse x. So according to this step we can write y equal to, instead of cos inverse I will write pi by 2 minus, so pi by 2 minus sin inverse of sin 2 theta. Hence now we can write y equal to pi by 2 minus sin inverse of sin 2 theta. So in this way we can convert cos inverse into sin inverse. Okay, now this term is to be simplified and then take derivative. First, for simplification, it is necessary that 2 theta should be in range of sin inverse. Then only sin inverse and sin gets cancelled. So here we have to show that 2 theta lies in range of sin inverse. So from given condition, that was minus 1 less than x less than 1, minus 1 less than x less than 1. Now from this range of x we will try to find range of 2 theta. So for this we have already assumed x equal to tan theta, so write all these terms in terms of tan. So for minus 1 I will write minus tan pi by 4. For x we will write tan theta, and for 1 we will write tan pi by 4. Now without tan I can write minus pi by 4 less than theta less than pi by 4. From this we have already got a range of theta, so now we can write range of 2 theta by multiplying 2 in all these terms. So multiplying by 2 I will get minus pi by 4 multiplied by 2 will get minus pi by 2. In middle term I will get 2 theta, and pi by 4 multiplied by 2, so we will get pi by 2. So range of 2 theta is obtained. So 2 theta lies between minus 90 and plus 90, which is already range of sin inverse. Minus 90 to plus 90, it is range of sin inverse. So hence we have already showed that 2 theta lies in range of sin inverse, right? So by simplification I will get y equal to pi by 2 minus 2 theta. Sin inverse and sin gets cancelled, so I will get 2 theta. Therefore y equal to pi by 2 minus 2 theta. Now we have assumed that x equal to tan theta. So from this, theta equal to tan inverse. So putting value of theta, y equal to pi by 2 minus 2 tan inverse x. Instead of theta we can write tan inverse x. This is simplified term. Now by taking derivative with respect to x, so derivative of y with respect to x is dy by dx. Derivative of pi by 2, which is constant, is 0. So minus 2 coefficient remains as it is. Pi by 2, for pi by 2 it is 0. Okay, so minus 2 remains as it is, and tan inverse x, derivative of tan inverse x is 1 upon 1 plus x square. So minus 2 upon 1 plus x square. This is our final answer. Let's see another question. Question number 14. Here given function is y equal to sine inverse 2x into 1 minus x square root of 1 minus x square, and range minus 1 upon root 2 less than x less than 1 upon root 2. This is given condition. For this question, whenever you are whenever in given function there is one root of 1 minus x square, then we can assume x equal to sine theta or cos theta. Now here outer function, it is sine inverse, so we'll assume x equal to sine theta. So by assuming x equal to sine theta, we will get theta equal to sine inverse x. Okay. This sum can also be solved by assuming x equal to cos theta. In both ways we can solve. But it is very easy when you assume x equal to sine theta. Now putting x equal to sine theta in given function, so y equal to sine inverse 2 sine theta and root of 1 minus x square. So root of 1 minus sine square theta. Root of 1 minus sine square theta. Now by simplifying, sine inverse 2 sine theta 1 minus sine square theta, that is cos square theta, and square root of cos square theta is cos theta. Now taking square root of any function, it is written in modulus first. It may be plus or minus. That's why we are writing square root of cos square theta in modulus. Now we have to confirm first where either it is positive or negative. That we have to show by from given condition. We will try to find that cos theta is whether it is positive or negative. We'll see. So but minus 1 by root 2 less than x less than 1 upon root 2. This is given condition. So from this condition, we have assumed x equal to sine theta. So write all these terms in terms of sine. We know that sine pi by 4 equal to 1 upon root 2. So minus 1 by 1 minus 1 upon root 2 means minus sine pi by 4. Like this. Now without sine function, I can write minus pi by 4 less than theta less than pi by 4. So here, as theta lies between minus pi by 4 and pi by 4, that means angle is between minus 45 and plus 45. So according to this, angle lies in first and fourth quadrant, right? First and fourth quadrant. So in first and fourth quadrant, cos is positive. So here theta is in first and fourth quadrant. Therefore, cos theta is already positive. According to all STC, cos is positive in first and fourth quadrant, right? So here, this our term is positive. It is confirmed that this term is positive. Now, without modulus, I can write cos theta as positive. So 2 sin theta cos theta. This again forms into here also we can apply formula. 2 sin theta cos theta means sin 2 theta. Therefore, y equal to sin inverse of 2 sin theta cos theta, that is sin 2 theta. Okay. Now sin inverse and sin gets cancelled only when 2 theta is in range of sin inverse. Therefore, again we have to show that 2 theta lies in range of sin inverse. We have already obtained range of theta here. Theta is between minus pi by 4 and pi by 4. So from this, range of 2 theta can easily obtained. Therefore, here we can write from this, range of 2 theta can be obtained by multiplying by 2. If we multiply 2 in all terms, then we'll get range of 2 theta. So minus pi by 4 multiplied by 2, minus pi by 2, 2 theta less than pi by 2. So here this is range of 2 theta, that is minus 92 plus 90, which is already range of sin inverse. So here it is confirmed that 2 theta is in range of sin inverse. Therefore, sin inverse and sin gets cancelled. So we'll get y equal to 2 theta. Y equal to 2 theta. Where again value of theta will be, we have assumed that x equal to sin theta. So theta is, if x equal to sin theta, then theta is sin inverse x. So put value of theta here, 2 sin inverse x. So y equal to sin inverse x is, this is simplified form. Now taking derivative with respect to x, derivative of y with respect to x is dy by dx, then coefficient as it is 2, and derivative of sin inverse is 1 upon root 1 minus x square. So 2 upon root 1 minus x square. This is derivative of sin inverse. Hence, this is our final answer, 2 upon root 1 minus x square. Just revise, I am just showing you again this solution of this question. First we are assuming x equal to sin theta, and then putting here, then to find whether cos is positive or negative, we are using this condition of x, writing in terms of sine, and then without sine, minus pi by 4 less than theta less than pi by 4. We are getting range of theta. Here theta lies in first and fourth quadrant, because minus 45 to 45 is the range. So first and fourth quadrant will be there, and in first and fourth quadrant cos theta is positive. So our term here cos theta is positive, and here 2 sin theta cos theta means sin 2 theta. Formula can be applied. So we are getting y equal to sin inverse sin 2 theta, sin inverse of sin 2 theta. And then we are showing that range of 2 theta lies in sin inverse. From this theta, if we multiply 2 here, in all these terms, we'll get range of 2 theta minus 90 less than 2 theta less than pi by 2. So minus 92 plus 90 is range of sine inverse. Therefore sine inverse and sine gets cancelled. So 2 theta remains. Y equal to 2 theta we are getting. And putting value of theta, so y equal to 2 sine inverse x. This is our simplified term. And then taking derivative, dy by dx equal to 2 upon root 1 minus x square. This is our answer. Now let us solve 15th question, friends. These questions are very important. That's why I am covering all these questions. Y equal to sec inverse 1 upon 2x square minus 1. And given range is 0 less than x less than 1 upon root 2. Now first, this variable term is in denominator, 1 upon 2 x square minus 1. Now here directly we can't apply any formula here. So first we have to convert sec inverse into its reciprocal term, that is cos inverse x, cos inverse. So if we convert sec inverse into cos inverse, then 1 upon 2x square minus 1 is inverted. We have to write reciprocal of this term, as we are writing sec inverse cos inverse instead of sec inverse. So here cos inverse of 2x square minus 1. We'll write reciprocal of this term, so 2x square minus 1. Now this is our given function. Just try to find which formula can be applied here. 2x square minus 1 is there, right? So as we know that cos 2 theta equal to 2 cos square theta minus 1. Now here this formula matches with this given term. We have to just assume x equal to cos theta, right? So let us assume x equal to cos theta. Now from this, theta can be written as cos inverse x. Okay. Now putting x equal to cos theta in given function, y equal to cos inverse of 2 cos square theta minus 1. Now 2 cos square theta minus 1 equal to cos 2 theta. So cos inverse of cos 2 theta. Now here we have to first show that 2 theta is in range of cos inverse. So given condition, from given condition we will solve 0 less than x less than 1 upon root 2. This is given condition. Now we have assumed x equal to cos theta. So here all these terms are to be written in form of cos. So in cos, we know that cos 90 equal to 0, right? Cos 90 equal to 0. So cos pi by 2 less than cos theta, and 1 upon root 2 means cos pi by 4. Now cos is decreasing function, my friends. So whenever you are getting inequality in form of cos and range is in first and second quadrant or first quadrant, then here you can see that angle 90, angle is 90 and 45. So these values are in first quadrant, right? In first quadrant we know that cos function is decreasing function. So as it is decreasing function, inequality is to be reversed. So without cos we can write first pi by 4, write this right side value on left side. So pi by 4 less than theta less than pi by 2. Inequality. Here this inequality is reversed. Okay, pi by 4 on left side and pi by 2 on right side. Why? Reason is cos function is decreasing in first quadrant. Whenever a function is decreasing, inequality gets reversed. Okay. Now we are getting range of theta and we want to find range of 2 theta. So multiplying by 2 will get range of 2 theta. Pi by 4 multiplied by 2 will be pi by 2. 2 theta, and pi by 2 multiplied by 2 will be pi. Now 2 theta lies between pi by 2 and pi, which is already range of cos inverse. It is, this angle is in range of cos inverse. It is confirmed. Therefore y equal to cos inverse and cos gets cancelled, so y equal to 2 theta, and theta will be we have assumed x equal to cos theta, so theta equal to cos inverse x. So writing cos inverse x for theta, cos inverse x, so y equal to 2 cos inverse x. This is simplified term. Now taking derivative of y will be dy by dx, 2 coefficient 2 as it is, and derivative of cos inverse x will be minus 1 upon root of 1 minus x square. This is derivative of cos inverse. Hence our answer will be minus 2 upon root 1 minus x square. Let's revise again this question. First of all, sec inverse function is given, right? So we are converting into cos inverse. So inside term will be reciprocal of that. So 1 upon 2x square minus 1. So reciprocal of this will be 2x square minus 1. Cos inverse 2x square minus 1. Now here we know that cos 2 theta equal to 2 cos inverse x, 2 cos square theta minus 1. So it is seen that we have to assume that x equal to cos theta. So we are assuming x equal to cos theta. So theta equal to cos inverse x, and then putting in given function 2 cos square theta minus 1, that is cos 2 theta. Now 2 theta should be in range of cos inverse. So for that we are solving inequality. So given range was 0 less than x less than 1 by root 2. Now writing in terms of cos, for 0 we will write cos 90 because cos 90 equal to 0. Then x equal to cos theta. 1 by root 2, for 1 by root 2 we will write cos pi by 4. Now angle, value of angle is between 90 and 45 and 90, right? So that means it is first quadrant. In first quadrant, cos is decreasing function. Whenever function is decreasing, inequality is reversed. So pi by 4 on left side, pi by 2 on right side. So, okay. So pi by 4 less than theta less than 90 will get. And from this, multiplying by 2 will get range of 2 theta. Pi by 4 multiplied by 2 will get pi by 2. And pi by 2 multiplied by 2 will get pi. So range of 2 theta is obtained. Now it is 2 theta lies between 90 and 180, which is in the range of cos inverse. This value is in range of cos inverse. That's why we will write y equal to 2 theta. Cos inverse and cos gets cancelled. And for theta we will write cos inverse x. Now taking derivative, for y we will write dy by dx and coefficient as it is. Derivative of cos inverse x is minus 1 upon root 1 minus x square. So our final answer is minus 2 upon root 1 minus x square. So here we have completed 5.3 exercise. I hope that you will understand, you will definitely understand whatever I have taught here. Thank you.